Last lecture, we mentioned that vectors in R2 and R3 can be spatially visualized as directed arrows from the origin. Under this visualization, we can calculate the angle between two vectors. For example, in the case of R2, suppose we are given the points x1, x2 and y1, y2. To calculate theta, we must compute the distances. Then, using the law of cosines, c squared equals a squared plus b squared minus 2ab cosine theta, with a equal the square root of x1 squared plus x2 squared, b equal the square root of y1 squared plus y2 squared, c equal the square root of x1 minus y1 squared plus x2 minus y2 squared. We have x1 minus y1 squared plus x2 minus y2 squared equals x1 squared plus x2 squared plus y1 squared plus y2 squared minus 2 square root of x1 squared plus x2 squared times square root of y1 squared plus y2 squared cosine theta. Expand the left-hand side. Cancelling terms, we are left with negative 2x1y1 minus 2x2y2 equals negative 2 square root of x1 squared plus x2 squared times square root of y1 squared plus y2 squared cosine theta. Isolating cosine theta equals x1 y1 plus x2 y2 divided by the square root of x1 squared plus x2 squared times the square root of y1 squared plus y2 squared. Thus, theta is the inverse cosine of x1 y1 plus x2 y2 divided by the square root of x1 squared plus x2 squared times the square root of y1 squared plus y2 squared. Likewise, we can follow a similar derivation to show that the angle between x1, x2, x3 and y1, y2, y3 is the inverse cosine of x1, y1 plus x2, y2 plus x3, y3 divided by the square root of x1 squared plus x2 squared plus x3 squared times the square root of y1 squared plus y2 squared plus y3 squared. But what about the angle between two vectors in Rn for n greater than or equal to 4? To reiterate, vectors are simply algebraic objects and we cannot visualize Rn spatially for higher values of n. So just as we defined the distance formula, we will need to define the angle between two vectors. Staring at the 2D and 3D cases, we are inspired to choose the following candidate for the angle formula in Rn. theta equals the inverse cosine of x1y1 plus x2y2 up to xn yn divided by the square root of x1 squared plus x2 squared up to xn squared times the square root of y1 squared plus y2 squared up to yn squared. If you look closely, you'll recognise that the denominator is the product of the norm of x with the norm of y. We can also give the numerator a formal name. Definition. For x and y in Rn, the dot product of x and y is x1 y1 plus x2 y2 up to xn yn. Using this notation, we formally define angles between vectors in Rn. The angle between two non-zero vectors, x and y in Rn, is the inverse cosine of the dot product of x and y divided by the norm of x and the norm of y. Again, we need to be careful. We must make sure that our definition makes sense. Specifically, between any two non-zero vectors, the angle theta should always exist. Suppose that the dot product of x and y divided by the norm of x and the norm of y is greater than 1. Then theta does not exist since the domain of inverse cosine is negative 1 to 1. Thus, we would like the dot product of x and y divided by the norm of x and the norm of y to be less than or equal to 1 for all non-zero vectors x and y. Before we can prove that this is indeed the case, we need to learn dot product properties.